All right, good morning. Welcome to week 3, our 5th lecture together. I hope you had a nice break. I was just saying to Tom, I actually had a day where I didn't turn the computer on, which is unusual for me, and got away entirely. Yeah, I was thinking of 1511 students actually when they think what I was doing yesterday. My partner works in aged care. One of the things she's been working on is she's got a VR device, an Oculus Quest 2, to try and get activities that are suitable for 90-year-olds. And they put Beat Saber on it. I don't know, some of you have probably played with an Oculus. Beat Saber is an incredibly popular game, I'm told. I didn't actually enjoy it much. But the problem she discovered with Beat Saber was it's got music really aimed at people your age rather than 90-year-olds. So she said, Andrew, can you put different music on it? So I spent a couple of hours trying in the internals of an Oculus Quest trying to add music, because Beat Saber doesn't seem to come normally with music for 90-year-olds either. But there are ways to mod it. And I discovered that an Oculus Quest has Android inside it, which is Android, you might have heard me mention, is a modified form of Linux. So because I know a lot about how Linux works, and I know a reasonable amount about how Android works, so I was able to poke around inside this Oculus Quest 2 quite easily, which my partners, neither she or her staff at the aged care place could do this. But you, and not necessarily after this course, but after a couple of comp courses, will have the same sort of knowledge. This same sort of knowledge about how Linux works, and then which can be applied in all sorts of contexts, and how coding works as well. You need to know how coding works as well. So it was an interesting thing. Yeah, I said even if you discover eventually you don't want to spend your life coding, or in a job that revolves around it, the knowledge you're learning in this course could be useful for you, even if you finish up looking after old people. All right. Enough of my weekend. Where are we in the course? We're entering week 3. Last week's lab we were getting up to speed. There were some interesting exercises. The challenge exercises last week were not typical programming. They're sort of weird logic puzzles, not unrelated to things we do in computer science. I think the hardest ones I thought them up because of things I've seen and worked with in implementing programming languages. So they're related to ideas that could be important at some parts of computing, but really they're weird logic puzzles that a real programmer wouldn't do anything like. And this week, the challenge exercises, some of them are sort of normal programming, and some of them are more, what would you call it? They're more sort of competition programming. Weird. They are normal programming, but weirdly difficult and You're saying, why? Do I need to do the challenge exercises? Should I do the challenge exercises? Well, I'd first to say, if you don't want to do the challenge exercises, you don't have to. They're there for people who find this stuff engaging, either picking it up pretty quickly, maybe because they've done a bit of coding before and want something to try out a bit more than the standard lab exercises. They get through the standard lab in half an hour and want to do more. So they're for people who want to do them. You can actually get, I think, close or exactly full marks if you don't do any challenge exercises. If you're aiming for exactly full marks, thank you, Tom. But it's recommended that if you can't stand to drop 0.2 of a lab mark, that you do some challenge exercises, so you've got in case you make a mistake in 1 or 2 or something like this. So if all you want is a perfect lab mark, yeah, do some challenge exercises. But if they look difficult or annoying, you don't have to. The other thing I would caution you, there are some students who want to do the challenge exercises, but maybe their time would be best spent on Math 1131 or whatever the difficult course you're doing elsewhere. So this course takes up a lot of time to start with. You may have the best use of your time maybe elsewhere.
A comment on that, if I may, Andrew. 2 comments, yep. I suppose. The regular comment is basically just the challenge exercises in future weeks. I think generally people think that they are slightly harder, mainly because they move from being challenges that test sort of the logic side of things or the general sort of programming tricks, more and more they become larger bits of work where it's an appreciation of all the syntax is useful and that kind of thing. So looking at the challenges in the early weeks, and especially the sort of early few challenges in the early weeks, can be a really good way of getting some of that market buffer if you want that, without having to worry about sort of the future weeks challenges. The other thing I'd say is if you don't know what nerd sniping is, you might profitably go and Google nerd sniping, because that is exactly what Andrew is cautioning you against in terms of not doing 1511 exercises at the expense of, Math 1A or something like that.
So yeah, decimal spiral, for example, it's quite simply stated, but actually coding it, it's a challenge. It's fun. All right. And I mentioned that I had a day away from the computer because, all right, things are going to get very busy. So I've said, if you try and you move your social engagements out of this the rest of term in general, but do try to take some time off, and you need to take each day, maybe go for a run for half an hour, do something of short duration different. And on weekends you're going to have to work some weekends in this and other courses, but again, take half a day off, do something, get outside, go somewhere, play basketball, play netball, I don't know, do something different, something unrelated to computer, something not staring at a screen preferably. So just some advice for you. All right. Weekly tests start this week. The first one will be released Thursday. I'll talk about in Thursday's lecture how it exactly works. You can ask any questions we've got there, clarify anything about that. This week's lab exercises are getting more difficult. We're tackling loops. There's some, and next week they wind up further. So prepared to spend a lot more time on the course. Hopefully, let me say it again, hopefully by now I'd be worried if you're not set up to work from home. So if you're not comfortably, wherever you live, set up to use your laptop, desktop, whatever, to connect into CSE and run stuff. So you can run DCC, you can run Autotest to work on your lab exercises. You need to be able to spend a significant amount of time every week coding, checking programs, working on programs. The other thing I'd caution you is you're thinking, this course is hard. It's me. No, this course is hard for everyone. And it's not just COMP1511. Introductory programming courses are notoriously difficult for students. So it's a big step learning all of this stuff. So today's lecture, we'll revisit a bit about loops. There are a couple of things I want to show you about, revisit, I guess, things we covered on loops, covered on while, and relevant in particular to the lab exercises for this week. Then we'll talk about coding style, completely different change of direction. How do we write code for humans? Not talking about how the code works, but how we make it easy for humans to deal with the code. And we'll come back, hopefully with time, to talk about functions in the last 20 minutes. On screen right now is a loop, a program we wrote in, I think, 2 lectures ago, which prints n asterisks. Why have I got that? So I was thinking, I've got a party to go to next weekend. I need a topic of conversation. So meet someone I haven't talked to before. I have to be able to talk about something. I thought prime numbers. So I need to be able to bring up something like, did you know that 51 is a prime number? I think, wait, is 51 a prime number? Well, that would be incredibly embarrassing at the party if the person I was talking to said, no, Andrew, 51 is divisible by 3, that's not prime. So I need a program that does some primality testing or prints out some prime numbers for me as a conversation starter.
Hey, Andrew.
So, yeah?
Are you sure that you've got something on your screen, if that's what you intended to do?
Oh, it is. Yeah, thank you, Tom. I don't
Sure.
have it. It's my face right now. Let's there. There is the program from. Here we go. Oh. All right. Apologies for that. It's a good thing we've got Tom there. Alright, so there's the program. Now I thought this program might be useful. I thought this program might do the same sort of thing I wanted to do for primality testing. Because why did I think that? Because I think if I want to know if 51 is prime, I'd see if it's divisible by 1, 2, 3, 4, 5, 3, you know, all the way through to perhaps 51. So how do I do that? Oh, let's first compile this. Let's copy this program. Yeah, I'd say to you. So this is a pretty common thing I want to do. You think you've got a C program or a program of any sort that fits the model, fits the pattern of something you knew you've got to do. So you take a copy of it and start with that. So what do we call it? We'll call it the program. I'll call it isPrime.c. And I'll use my mad. Did you get it? Schools, and there it is. Alright, it doesn't, this of course doesn't. So let's fix it. We'll enter n, and it's got to print out whether n is prime. Oh, that prints out an asterisk every time. We'll just print out n for now. Let's get something working. Note to use for new line. Alright. I don't think I need that last printf. Oh, I think this is actually a tute question. That's a common mistake I make. I'll be giving a lecture and I think, oh, this would be a great program to show students, but forgetting that I thought that last year and added to the tute questions. But it doesn't matter in this case. Tutors do get a bit grumpy if you they set up to give question 3 and the students say, but well, Andrew talked about that in the lectures, so I try to avoid doing that. Alright, so I think this, I enter in there and that will count through. Oh, it's loop counter. Yeah, loop counter, that's what I want to print out. Okay. Alright, so given 51, that loops through 1 to 50. 0 to 50. Oh, interesting. Alright. So we've got that sort of structure. If I want to check that if 51 is prime, I've got to loop through all the possibilities and check them. At this point, I think I've got to rename. In fact, you saw there where I printed out n here. That's a classic sort of mistake you make with poor variable names. So my variable names are n and loop counter. So it doesn't not just confuses other people, your tutor for example, reading your program. It confuses me. I get confused in my own head about what each variable holds because they don't have meaningful names. So I see this a lot in exams where students know they're under time pressure and they're coding. I don't have time to give a variable a good name, or just call it x, y, z, and then they get confused. Z, it's holding that, and x, or it was y holding that, or you see bugs that they wouldn't have had if they'd taken the time to give their variable a sensible name. And there's no marks for style, by the way, on the exam. So it's not a matter of the exam marker reading your code and saying, oh, that's a poor variable name, -1. It's a matter of you not even be able to write correct code because of poor style, which we'll come back to. So I'd call this is a possible factor of n. You could come up with a better name for n, number being checked for primality, but and I'm going to go to the shorthand, the shortcut we saw for checking for sorry, not for checking, for incrementing. So plus just a shorter way of writing possible factor equals possible factor plus 1. Sorry, let me just see if I can turn on something. Alright, there we go. Alright, so that's... Now we want to loop through the possible factors. We don't care about, we don't want to check 0. We don't want to check 1. 1's a factor of everything. We probably want to start at 2. And we don't want to check n itself because n's a factor of everything. So this should give us all the possible factors we have to check. Alright, enter n. So I'll put in 19. What are the numbers we have to check for 19? We have to see, is 2 a factor? Is 3 a factor? Alright. Now, students are often, not students, beginner coders are often impatient to get straight to the solution. But you'll get there faster, you're more likely to get there. You'll have it, you'll be, you know, you won't be still working on the program at 4 AM if you try and take steps. If there's an intermediate place you can get to where you can write a legal program, check it works, run that, compile that, get all of that working, and then move on to the next part of the problem. So here I've come up with my problem is checking whether 19 is prime. So I've written a program that just prints out all the factor tests we've got to do. We've got to check all of those. And I can inspect that and see, yeah, it's the right range. To check whether 19 is prime, I want to check 2 through to 18. They're all there. I've got the bounds right. That's always the question, isn't it? What are the bounds? My code has got that right apparently. So let me just check if my annotator's working today. Oh, not there. Let's fix that. Can we scribble on it? Oh, we can now. Lovely. Alright, yeah, so I'm talking about this and this. Very hard to get right, and you'll discover that in this week's lab. And the classic thing is just to have them almost right, off by 1. And that's the sad thing about coding, and in general, it's brittle. You just have to be off by 1 bit. One tiny amount, and it breaks everything. There are lots of other circumstances in dealing with things where you're off by a little. That doesn't really matter. Physics is really interesting. You do see physicists doing calculations and estimations, and there are lots of subtleties in physics that they're not really going to affect your calculations and make them incredibly complex. And they say, well, we just ignore this bit and we'll be close. Sadly, you can't do that with software. Well, I guess you can with complexity analysis. If you do algorithms, COMP1511, you can do a bit there. Alright. So I've got these possible factors. How do I check? And we've seen percent used for checking this. Percent gives me the remainder after x% y, gives me the remainder after dividing x by y. So there is my test to see if something's a possible factor. Again, it's not quite what we want. The message we wanted to do, our final program's got to say n is prime, n is not prime. But let's see if we've got the factor testing right. All right. So I'll put in 17. Oh, actually, no, I'll put in something that's prime. Sorry, not prime. It's got factors. 15. 3 is a factor. 5 is a factor. We want to print one message. We're going to print either. We want to print this prime. There are 2 possibilities down here. And one line of output. There we go. So, so we've got. Does that printf look weird? It does look weird to me. It's actually a problem when you're learning. Your tutor, who's done quite a bit of coding, will just take one look at your program and just look at the printf and go like that and go, oh, that's weird. Almost instinctively. And why? There's a %d, but there's nothing to say how to fill that gap. %d says print out an integer, and the integer will follow, but there's no integer following. So DCC will give us a message about that. But let's fill both of those in. And now, this is classic. Yeah, this actually worked out well. This shows you something that's really nice. What if test can I put there? I mean, that's what I want to do, isn't it? I get to finish my program and let's print out what we have decided. Have we decided n is prime or not prime? If we get in here, we know n is not prime. If n's got a factor, if we print a message here, n is not prime. But how do we know if we printed a message? How do we know if we executed line 16? We want an if statement that says, if we executed line 16, print out this. If we never executed line 16, print out that. I can see whether we executed line 16 because there's a print comes out here, but that's not helping me. And at this point, you can sit there sort of trying all sorts of things, but there's not actually anything you can do on line 21. As this program stands, you can't finish this and put what goes in the brackets. There's no if test that, well, I can't see an if test that actually works there. There's certainly no obvious if test that works there. So what do we do? And the solution is introduce another variable. And this is often hard for coders to see as you're learning to code. Is if you don't think about introducing another variable, you won't get any further with this program probably. You've got to add another variable. I'm going to have a variable called n factors, and I'm going to increment and count the number of factors. So I've added a variable called n factors, and I'm going to count. And here then, if n factors is greater than 1, greater than 0. Yeah, if there's any factors, print out that. Actually, I think the last one would have worked. Oh no, it wouldn't have worked. Yeah, that'd be a nice one for you to think of when that would have failed. Alright, lovely. Let's compile that and see if that's got me a working program. Line 22. There's line 22. N factors undeclared. Yeah, it's something we're going to see over and over. Before you use a variable, before you use anything, actually, we'll see that with functions, but before you use a variable, C has to have been told about the variable. You have to have said, I'm going to use the variable X and it's of type int. I'm going to use the variable Z and it's of type double. You have to declare the variable. C will then set, the C implementation will then set aside a place to put it, the appropriate number of bytes, and knows about it. It also avoids us, if we make a typing mistake, then C can pick up our errors for us because we won't have declared the variable. But why? I have declared the variable here on line 16, and there's a special thing happening here. There's a clever thing happening here. Whatever occurs between the braces, whatever occurs between any set of braces, the technical term is a block or a code block. But whatever happens between the braces stays within the braces in terms of creating variables. So if I create new variables in those braces, they have no effect anywhere else. They don't exist anywhere else except between those braces. Think, well, that seems a bit restricting, a bit silly. Because it's restricting, because it's limiting, is what makes it good. It makes it easier for us to read the program. It makes it easiest for if we wanted to mathematically prove properties about the program, analyze the program. It makes it easier for the compiler in some senses maybe to produce faster code. The restriction that a variable between braces exists only between those braces is a very good thing. At the moment, you may just think, it makes my life harder, but no, you'll discover eventually, no, it makes your life much easier. Braces are their own little world for variables. So we really want that variable out here, and that will fix my program, which is now perfect and cannot possibly have any bugs. That, by the way, there's a sort of a fundamental thing. We believe that essentially all programs have bugs. Oh, though in this case the bug is so obvious that DCC is pointing it out. Now, these variables out here, by the way, also exist only between braces. They exist between the braces of main. So there's a brace there for main and a brace there for main, and those variables exist only from, well, in fact they exist from where they so n factors exists from line 12 through to line 27, where's the closing brace. There are other sorts of variables in C. We'll come back to them, but you don't need, well, you barely need them at all in this course, and you certainly don't need them for anything we do in the near future. And in general, they're things we try to avoid. So this is the sort of variable you'll be using for most of your C programming and almost all your C programming in this course. That said, I haven't really addressed why DCC is printing out this message. N factors is uninitialized. Oh, look, I'm saying here plus it. Isn't that giving it a value? I know that you can't use a variable value before you give it a value. That's less obvious. That's one of the reasons I think plus can confuse students a little. It's less obvious what it is. Let me take it out to its long form. All right. And this is the long form, and it first gets the value of the variable, calculates that plus 1, and puts it in the variable. So the very first time we do that, there's nothing in the variable, or you'd say the variable is uninitialized is the term. And that's bad. That's undefined is what I'd say, but DCC won't let you do it because it's an error. It's a classic C programming error. We're big on it because this sort of programs where they haven't done carefully checking for this, with this sort of error in it, create the possibility for, particularly for security holes. but also for programs that behave erratically and unsafe and are not robust. Now, it's easy to fix, of course, once we've realized that, is I'll put the plus back just because we like the plus. We can just say, start off with, we know about no factors, and as we go through the loop, every time round, we're checking one number and incrementing n factors if it's correct. Alright, this time I think I have a correct program. This time I think alright, enter n 45. Oh. My if test. See, that was accidental. Also common. I've got everything worked out. Just got slightly confused about what the test was. Fix that. Yes, I know that probably all of you spotted that in the chat. 45 is not prime. 47 is prime. Oh, look at this. See, so before saying to someone, did you know that 51 is prime at the party? I could have checked. Oh, I can instead say, did you know 53 is prime? Yes, it is. Alright. So that's checking for primality, given a number, checking for primality. Now, I wanted to modify this program now. Well, I'll do that with CP. You can just do it in the editor, of course, but I need lots of primes. So I'd like to have this program automatically write out 1,000 primes for me. Can we do that? It's more complicated. So rather than entering a number, I just wanted to print out the first 1,000 primes. So let's open 1,000 primes. Oh, there's still a bad comment there. Should have got rid of last time. How do we do it? So we want to check out, is 1 prime, is 2 prime, is 3 prime, and so on. All the way up until we've got 1,000 primes. So we're not going to enter n or scan fm. We're going to loop through n, aren't we? We'll start off doing this, and then perhaps modify it. Does DCC have a... Let's see if we'll let indent... Oh, it does. There you go. Alright, where are we going to start? I guess we start at 1. Is 1 prime? It's a good question, actually. That's a fascinating question, which I'm going to avoid then. Apparently thinking has changed among mathematicians in the last century about whether 1 is prime. You can research that and discover more about it than me. Alright, so there's my number to print out 1,000, my program to print out 1,000 primes. It has one huge bug and a couple of, at least another smaller one, but let's see if it compiles first. DCC doesn't. Alright, so this is a test for you. This is a question for you. If you think you know your loops, you've picked up your loops, what does this program print? How many lines of output does it print? And what is it? Can you reason about this program? Hint, it doesn't do anything like what I want. All right, that's a little sad. It's in it. It's printing out 2 is prime constantly. It's not terminating. You'll certainly write programs that don't terminate in this week's lab. We haven't given you good lab exercises if you haven't experienced that. All right, I'm going to interrupt it by typing Control-C. It'll stop. DCC will tell me where it is. Oh, look at that. It tells me the variable values as well. N is 2. How can N still be 2? We can actually think about this. We can track this logically. There's N. Oh, we use N there. Where else does N appear in my program? Oh, there's N there. Yep, used there. N factors, that's a different variable. Oh, N's used there as well. N gets used 3 places. Oh, printed down here as well. Used 5 places. Alright, that's sort of interesting. But where does N get changed? Where does N take new values? First value there. There's no other assignments. Nowhere else in that program does it say N equals this. So what can you say about N if you're trying to reason about this program? N gets assigned 2, and then it never changes. It's always 2. N is in fact constant. We could hash define N, except we don't. We want N to change. So that does seem to be a problem, doesn't it? You'll work on this. It comes slowly, but try and reason about your programs. And what I forgot was to increment N every time round the loop. So I got a loop that never terminated because the test was N was less than 1,000 and N never changed. I'm a little surprised the compiler didn't warn me actually. I guess, yeah, maybe not. It would depend. If you were writing a compiler only for people in first year programming courses, you would actually pick that up. Some of the things the C implementation does, DCC does, to produce fast machine code, to translate the C into Intel instructions, in this case, that run really quickly, would also let us pick up that this loop never terminated. In general, we've said you can't test this, but in specific cases like this one, it's quite simple to determine the program never terminates. Alright, I've changed that. Oh, I haven't saved it. Note the little asterisk up there. For those of you who haven't missed it, gedit has a little asterisk there to say I haven't saved it. Let me. I've saved it. Look at that. Goes through all the numbers. Well, who cares if we're about non-prime numbers? I'm dumping those lines. Alright, let's just print a message if they're prime. Let's compile again and run again. Let's compile again, sorry. And now run again. Ah, look at that. Printing out prime numbers. Did you know 827 was prime? Yeah, it's at the dinner table tonight, and everyone's saying, "What did you do today?" I discovered that 947 is a prime number. But everyone will be impressed. Now, this is not quite doing what I want, is it? It's a nice program, and actually, this is the sort of pattern for the stuff you've got to do this week. But this loop executes a fixed number of times. We know in advance it's going to execute, well, 998 times. 997 times, I think, checking the prime numbers. I said I wanted the first 1,000 prime numbers. This actually gives me the prime numbers less than 1,000. How would you change this condition so it stops when we've printed 1,000 prime numbers? So I want to change that so it stops when we've printed 1,000 prime numbers. And again, this is coming back to this same thing. There's actually nothing you can put at line 8 to do that. Well, just at line 8. You can't just change line 8 now and put something there. There's nothing you can replace n less than 1,000 with. Well, I guess if you know what the 1,000th prime is, you could invent that. That's true. Without pre-computing what it's supposed to do. What I've got to do is add another variable. If I add another variable, the prime's found, put it here, and I say, well, prime's found less than 1,000. Now I can print out 1,000 prime numbers. There's someone in the chat saying I've got a super, well, they're not saying it, but the subtext is I've got a super clever way that doesn't involve another variable. Yeah, that's possible. Maybe I'm not smart enough to see it. That's quite possible. Then the question would be, though, is the version with another variable simpler, more obviously correct, easier to understand, easier for other people to maintain? So you wouldn't necessarily use a solution that used 3 variables instead of 5 if the version with 5 variables was more obvious, simpler, you could be more confident it's right, easier for people to fix. So making your program shorter doesn't not necessarily make it better. Using fewer variables, not necessarily better. Coders often engage in those sort of games, saying, I can write that program in 5 lines, but they probably shouldn't write the program in 5 lines. Alright, so that now should print the first 1,000 prime numbers. I've actually got a trick I can do to check. This is do COMP1511 with me, and we'll do this sort of thing a lot, but that's a command line way of checking how many lines of output I'm getting from the program. As I said, I'm not going to tell you unless you can. Well, you can research it, but come and do COMP1511 with me, and we'll do that sort of thing at great length. But printing out the first 1,000 prime numbers. Well, good question in the chat. Do we need n++ there? What happens if I take out that n++? Yeah, it's an excellent question, isn't it? That n++. We don't need it for here now, do we? We don't need it to control our while loop. N has gone from controlling our while loop to not controlling our while loop. What's controlling our while loop is this primes found variable. But do we need n? We're using n here, here. We're using n on lines 12 and 13. So we do need, still n, because we want the loop to work systematically through the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. We do need n. You can grab the code yourself and experiment with deleting n and see what happens. Now, does this loop terminate? Well, actually, I'll make this larger. That's a million, and that's a billion. Does that loop terminate? So remember, this is Turing's problem. Is given a program. He had a very simple way of defining programs, the Turing machine, but given a program, can you say whether it stops? Does this program stop? Well, does the program stop? actually that's a multi-level question. In an abstract way, the program stops if there are more than 1 billion primes. Are there more than 1 billion primes? Well, mathematicians have worked out a way to show that there are an infinite number of primes. So we know the program stops to that extent. There is a problem here to do with, will it find 1 billion primes in the range of integers that fit in an int? And no, it won't. So we'll get into a runtime error with a C program. But we're talking second and third order issues there. Don't worry about these. Are not things you have to worry about for your coding up of while loops for this week's lab. All right, let's. There was one more thing. Oh, there was one. Yeah. So if you put a number like this in your code, your tutor will say, "Oh, it's great. Your program works, but that's fantastic. But the style could be better." We don't like what people often call them magic numbers, which are just integers appearing in your text. And it can be a bit subjective. I'll talk about why it's subjective, but that one's clearly not. That should be hash defined. It's a constant. It's hard to come up with a name. N primes to print, I guess. That will do. 1000. And that's a very important style change for this program. If someone wants to modify this program, what's the thing they most likely want to change? It's this. They want to print out 10,000 primes, 20,000 primes, 100 primes. By shifting that value into a hash define, it makes it easy. They think, I can just change this. They don't have to worry about what these other numbers are. Now, I've said this can be a subjective issue. Should you hash define 2? I've seen programmers, very sort of careful programmers, that would hash define 2 as smallest prime or something like that. So that's you could maybe. It's much less important. It's not something that can be changed necessarily. But it gives a meaning to that too. So yeah, hash defining it is not a bad thing to do, but it's crucial for a value like that. Absolutely essential for that sort of thing. All right, I'm going to ask Tom if there are any questions about this that I haven't talked about, and then move to a different example.
The only thing, I think most of the questions have been answered. Someone has said that they're a bit confused about the second if statement, particularly why I think the question was around like why is it n factors equals 0. So that might be good to just go over quickly.
Yeah, actually, perhaps in my program development, I should have printed out what n factors were. That would have been actually, yeah. Well, we can actually show you that. So actually, excellent question. So you're wondering about that sort of thing. What do you do? Let me show you two things. One is, if I'm printing out 1,000 lines of output, my program's a bit hard to work with. So often we deliberately go to simpler cases. So we'll make my program print the first 10 primes. So if I've got my hash define right, just by changing that, it'll print 10 primes. The first 10 primes, which are 2 to 29 apparently. All right. I want to find out what a program does. There are a few ways to do it, but this is the one I like. This works almost everywhere. This is sort of a generic, easily all sorts of possibility. You go to working on operating systems, device drivers, things like this. You'll typically have some way of doing something like this to get information out of your program. If you work on tiny embedded chips, yeah, maybe not. Though often you can get a little ASCII line and things coming out. So we add statements to our program to get information at a particular point. So I want to know what n factors is. You add a printf just for the purpose of getting information about what's happening at line 20. saying, couldn't they tell DCC to tell me that? Not DCC. DCC doesn't have a way of doing that, but there are C implementations that do have just that sort of thing that will let you inspect it. And language implementations designed for you inspecting what's happening in the internals of the program. All right. Oh, it would be clearer. Yeah. Another hint is students debugging often just write out the number. Take the time to put a bit of extra text in there. Say n factors is %d, and we might write out n as well. N is %d, n factors is %d. And this is a good thing to do with examples from lectures, to get them home, compile them, run them, but then, I don't quite know how the loop on line 17 works. Add some printfs. See if you can understand what's happening with the variables. All right, and hopefully that if you read that, look at that, hopefully answers the question, that excellent question that Tom's passed on. So we come down, for n is 24, for example, n factors is 6. So we get to line 20. This loop has counted the factors of n. It's gone through all the possible factors, incremented n factor for each factor. Here we're printing it out. N is 24. It has 6 factors, not prime. 25, 1 factor. Oh. There must be a word for a number that has 1 factor. You can come up with one, perhaps. Coin a neologism. N is 29. N factors is 0, so we write out prime. So that printf helps explain that. All right. There are lots more things you might want to not quite know about that program. I want to figure out. And this week's lab exercises, there's a lot. This is, in fact, I might have gone too far. This might be a bit of a spoiler for one of the lab exercises, but that's all right. It's week 3.
Worth also noting, somebody in the chat has asked a question like, how do you display the individual factors that you've found? And well, I don't think we're going to go to the extent of doing that in the lecture. That's one of the interesting things you might want to do if you get this program for yourself. Have a look at how would you find out those individual factors. You can even turn this into quite a useful program for any maths that you're doing if you're trying to figure out factors and that sort of thing. Comes up occasionally.
All right. Oh, actually, sorry. I've got confused about which window I'm typing in. No. I think I have a program here. Square.c. Okay. This is another spoiler for the lab. So if you really want the lab exercises for a challenge, don't listen to the next bit of the lecture. But I wanted to modify this program a bit. Read an integer n, print an n by n square of asterisks. Let's make sure it still works. It can be sad. There's things programmers call it bit rot, where you go back to a program that used to work and you come back 6 months or a year later and it no longer works because something has changed about the world. All right. So this should print out 144 asterisks. Lovely. All right. So that's in a square. What happens if I would like to print some other things? What would happen if I wanted to print a triangle? So let's change our name to triangle.c. Yeah, you're saying which triangle? There are so many. That is true. So what I'm thinking is, rather than given 3, it'll print out 1 asterisk, 2 asterisks, and 3 asterisks. Which part of the program do I vary there? Yeah, there's no comments here, is there? That's not very good. Oh, what comment? That's some poor coding. would help to have a comment. What is this? I'll even try and make it clear that that's a variable. Some fake markdown. Print a line of column asterisks. So that's what this code does. And that finishes the line there. And then we go to the next loop. Alright. Oh, print a, no, it's not column as well, it's n asterisks. Sorry, what am I thinking? Print a line of n asterisks. So we enter n, and it always, if we enter 3 for n, it always prints 3 asterisks. We enter 10, we print 10 asterisks. How will we get a triangle? What we want to do is print a line of, well, row is 0 the first time, so I think we want a line of row plus 1 asterisks. Now I've got this right. If I say, well, column less than row plus 1, that might get me my triangle. Oh, and of course we have to compile the right program. Alright, let's see if we can get it. Oh, look at that. Just a single change. My logic was flawless. Beautiful. Let me show you I want more interesting patterns. So let's introduce an if here, and on some basis print a different value. So what do we do? If column is, oh, I know, column's greater than 4, let's print what character do we like? An at? Alright. Else, let me get this right, brackets else, print an asterisk. So sometimes we'll print an at, we'll make a decision, either print an at or print an asterisk. What will that do? So the lab exercise has, I think we've got 2 lab exercises revolving about this sort of thing, which involve loops inside loops with ifs. Quite complicated ifs, because you see it graphically. You see the it's easy to see the impact of our loop. So it's a good way to practice writing loops plus if statements, which you use in many places in programming. It's just ubiquitous. But because we're writing out silly ASCII patterns, it's such an easy way to debug them. So here's my weird triangle one with the decision in there. And if I print out 9, oh, look at that. It changes what it writes. So the bottom half of the triangle becomes at. How weird. So there's all sorts of possibilities for what you could put there. And then you can get different patterns of ats and asterisks. And you could go back to doing a square. In fact, oh yeah, let's go back to doing a square now. So that changed what we're writing out, but let's go back to writing out a square, which was column less than n, a square of characters. And now use the decision there. No longer writing a triangle, but oh, look at that. Asterisks and ats. Alright, so I think that's my hint, my sort of lead into the lab. The tutors will have a better go in the tutorial. There's some tutorial questions I think leading into these. I thought I'd like to at least chat about them a little bit in lectures. So there's modifying this to get a different shape other than a square, but adding a decision here about what character we print to get patterns. And there's all sorts of patterns you can possibly get there. All right. And yeah, it's nicely timed. I want to switch to talking about style, but if Tom tells me there's any good questions in the chat that I need to follow up on.
It doesn't look like there are too many. The only thing I'd say is I suppose we should take a break at some point given it's 10 o'clock.
I think it's an excellent time to take a break, so we're going to take a 5-minute break. I strongly urge you to get up, stretch, focus your eyes at a different length, that sort of thing, and we'll come back in 5 minutes to talk coding style. So talk to you then. be. There. Alright, welcome back. I hope you had a nice quick break. Alright, we're going to talk about programming style now. Why we do it, what we have to do, and help you onto your first steps with this. Before we start, by the way, I was thinking, maybe you're worried. Sorry, excuse me. Maybe you're worried the stuff you're learning in these exercises in these weeks is all about prime numbers or writing out ASCII pictures. We picked domains like this for exercises because they're excuse me. They're ideal for you to learn. They're familiar, comfortable, easy places to learn. But the programming patterns, the ideas you're learning, are applicable in so many places, and not just C. As I've said, you might use using R with statistics, and these lessons you're learning about loops and nested loops and ifs just carry straight over to R and data analysis. So we work with simple ideas, simple domains, so we can focus on learning how to write correct code. Later on, you can use those. You can apply that code to interesting topics, if sadly you don't think prime numbers are interesting. You'd be wrong, of course, but if you don't, then you can apply your coding ideas to other areas. All right. Yeah, I keep saying this again and again. Good coding style helps humans read your code, and the humans that it helps read your code, very much it's the lesson you learn over and over again. If you're coding for a while, is you come back to code. You have to come back to code you wrote months ago or a year ago, and you're helping future you read your code. But I've said often it's you at the time. You don't choose a variable name wisely, and then you get confused reading your loops. Easier to understand. Understand in what way? Understand for a human to think about it and understand what this code does, understand the meaning of this code. A human to understand the code is correct, not what it only does, but if they know what it's supposed to do, is it correct? Often we write code where it's hard, there's not an exact definition of what is correct, but then we want to understand what the code does. And perhaps easier to do manual, automatic analysis as well. Yeah, less mistakes, faster overall. Yeah, speed. All right. So what's good style? Indentation and bracketing. What do I mean by that? Whoa. What's happened to my... I've lost my gedit in the... Oh, no. There we go. Up in the workspace. Ah. All right. If you haven't figured it out, up here, XFSC lets you have different workplaces where you could work on two or three. So if you're taking 4 comp courses, you could be working on all 4 simultaneously and clicking on having the windows open for one here, and so on. Let's just focus on having one window open. So indentation is shifting it across that many positions to make it visually obvious that the if part here is that. Alright, so for that if, it's pretty obvious. What about for this while loop here? What's its extent? Less obvious, isn't it? So where you have nested while loops, nested indentation becomes crucial to understanding what's the extent of this while loop. Oh, it runs to there, making it visually obvious that this while loop runs to there. So where you have complex code, and you're getting to write more complex code in this week's lab, doing that makes it clearer. So indentation, crucial, absolutely crucial. Now, if you show your tutor code with a bug that's not properly indented, what I'd like the tutors to do, sometimes they're too nice to do this, but what I'd like the tutor to do is first say to you, no, it's not the cause of your bug, but your code's badly indented, I can't read it. Go away, indent it, and then come back, and when it's properly indented, then I'll look and see if I can give you some advice about finding your bug. One of the reasons I tell the tutor to do this is there's like a 50% chance that in properly indenting your code, you'll spot what your bug is. As you lay out your code properly, suddenly you'll see, oh wait, that if statement's not right, is it? Because you've misunderstood the extent of the if statement because it's not properly indented. The other is it's easier for the tutor, so you should be making it easy for the tutor to find your bug as possible. Make it easy, giving them a properly readable program to look at. So don't be surprised if your tutor says no, fix this up, and then we'll look at that. Students get frustrated because they know the style isn't their bug, or they think the style isn't their bug, but the tutor will say no, fix your style, then we'll talk. The same would go to putting stuff on the class forum. All right. No, that's the wrong window. This is the window. Names. Actually, I would say, well, yeah, this is the next thing. Names, choosing good names. And I'd like to say it's easy. No, choosing names is hard. Think about names. Choose good names. Names that have meanings. Names that relate to the concept in the variable. And when you're naming functions, which you don't know how to write functions yet, even more important. The importance of the name varies with the importance of the variable, function, or whatever else you're naming. Some variables, they're used for 2 lines as a loop counter, not so important. Other variables hold a crucial value and they're used over 20 lines, and their name is incredible. Another thing of good style is no repetition, but you don't know how to do that yet. But when we talk about functions, we'll get to there. That's a week or 2 away yet. We don't like repeating code, but you don't have the tools not to repeat codes. Clear comments. Yeah, adding extra information, not executable code, things saying what this code is going to do. And this perhaps one is underrated. Consistency. And this is the hallmark of good coders. It's not not their fidelity, not the way they exactly follow a particular style or particular rules. It's that they, in more complex situations, they come up with a way of doing things consistently. So when they get to other aspects of coding or other aspects of dealing with data, they come up with a way of doing things consistently and follow it. So you're looking at what they're specifying, what they're doing, what they're writing, and you figure out, they're doing X, Y, Z, and then they're following it every time. Consistency. So this sounds, you're saying I'm an artistic person, I'm a creative person. This doesn't sound like me at all. Yeah, it's in some ways this sort of thing is the opposite of what you might do creatively in some contexts. Oh, all right. There's some code that's hard to read. I'm going to come. I think there's better slides to come. All right. No. Now we'll pull this up and then look at what's wrong with it. So I have this. This is a piece of bad code which I've got here ready to go, I believe. Code style bad.c. Yeah. I didn't write this code. Mark Chi wrote this code, and it's. So this is the dice checking program that we wrote in a previous lecture. It's a correct, I think it's pretty much a correct program, but you look at it and how do you know what it does? So it's almost impossible to read. It does actually have comments in there. It's got variables, but how can you figure out what it does? It's really confusing. There is actually a contest every year run by coders to deliberately do this, the obfuscated C contest, where they write even see in more difficult and to understand ways, it's generally not considered a virtue. So if you had a job, for example, as an intern and wrote this code, it might work, and the people using the code would never know what it looks like, the source looks like. They'd just run the dice check program and see it work. That's fine. But what happens next 6 months' time when the next intern comes in and their manager says, can you get the dice check program and update it to do this? And they look at this, and frankly you'd look at this and you'd almost start again rather than try and fix this program. You just can't figure out what it's doing, you can't add to it, it's just a nightmare. So let's see if we can systematically, I've got some slides here suggesting what might be wrong with this program. Yeah, alright, so the advice here is perhaps don't throw away the code, maybe we can fix it. It's hard. Oh, here's a comprehensive list of things wrong with the program. Right, header comment doesn't show program intentions. Let's have a look at this. Alright, there's a header comment there saying don't do this, but really the header comment should be input 2 dice and right. Could be better than that, but that's a start at least, saying something like what the program does. Alright, one thing fixed. Let's talk about the dice check program. No blank lines separating different components. Yeah, alright. Let's see if we can add a few of those and show if that, see if that helps. Oh, well, we can put a blank line there and a blank line there. Blank line there, blank line there, I guess. They're variable declarations. This bit does. Alright, separate out the scanfs, that's the input, and that's the if statement. Yep. Right, that's another if statement. Yep. That's another chunk of code. Ah, there. That's it. That's another chunk of code. Alright. Few blank lines have got the program more manageable. We can see pieces of it and get some idea of what's happening. Why? Let's just break down the program and consider bits in isolation. Start into it with bits, so I can look at lines 15 to 17 and they do one thing, and they're isolated, so I can start thinking about what they do. It's still hard. It's still very hard. See if I've got any more hints for fixing this. Don't put multiple things on the same line. One action per line. I'm sorry, I've added the indenting, but it's not, I guess they're sort of related, so that's not so bad. But let's come down here, put the scanf and the printf on the one line. Yeah. So don't hide things. If something's on a line after something else, the C compiler says, oh yeah, okay, that's fine, but it hides it. I could do more of that, but you can see that getting clearer. The next thing though is consistent indenting to show what's what. So we take, these are one step in. the if statement is one step in. That's, oh, it's not one, I don't know why I did that. But one step in, one step in. And there, one step in. So that if statement, suddenly it's getting easier to read. This comment could make more sense, couldn't it? Something resembling that. A comment could be better, could give examples or things like this, but oh, there's a bug there as well. But let's not worry about the bug. Inconsistent indenting. We fixed inconsistent spacing. Yeah, spacing. Let's look at this spacing as well here. Look at how this if statement's spaced, how this is spaced. They differ. DCC doesn't care if there's one space there or 50. C just says the programmer can put any number of spaces there. 0 spaces, 50 spaces, 1,000,000 spaces. DCC doesn't care. But it's much easier for humans to read the program if we consistently follow a rule, and a space around the operator makes it easier to see what's happening. So there we might put space that there, space that there. So these spaces matter in terms of keeping things readable. I don't want to do the whole program necessarily, but it's a lot of work. Alright. What's still wrong here? A. What's A? What's X? What's Y? So X holds, yeah, if you're reading down here, what's X? You're going to have to go back up and figure out, yeah, so alright, you're the intern who's got this program from the previous intern, and you've got to fix it. So you're reading it, you're going, oh, well, what's X? What's X? What's X? Oh, X is up here, there's no comment, what's X? You could put a comment here, I guess, saying what X is blah. So that's good, but better is give X a name, so the name tells you what X is. So you can figure out by eventually reading the program, it comes in here after this message, it's how many sides are on your dice. So it takes time. You look at this and you go back, back, back. It shouldn't take that time. What's a good name? Die sides. In die sides. There's many things, many possible names, but something like, yeah, how about in die sides? That's the one I'd choose. The whole program won't compile now, but and that's suddenly I feel a bit, there's a horrible feeling that's just fading away there. This bit of code makes more sense. I can read it and see is what it means. There's also A here though, and it could be called first die. And we can make those changes there as well. So changing that would then make the code more readable still. Yeah, I would actually, well, I mean, indenting and spaces are easy. They're just sort of rule following. I could teach someone who did not any of the deeper stuff about C, not how to code in C, just rule follow. Say space this across, space this across. I guess you'd sort of have to know how C works to do it. Put spaces there. Do this consistently, and your code will be easier to read. Yeah, but that's easy to follow. Choosing good names often takes some thought, and it's really important. It's the difference between code being clear and code being incomprehensible often. Yeah, alright. Comments don't make any sense. That's a problem we see. You don't see it with real coders so much. You see it with students because they know, oh, I've got to put in comments, there's marks for comments. I'll just put a comment there, x equals x plus 1. I'm adding 1 to x, or I'm doing this because it said to, or yeah. So think about where comments add meaning to your code. There was inconsistent bracketing. Bracketing's not dender. Inconsistent. There's some incorrect code buried in there. We'll leave that as an exercise for you. I can see 2 bugs in there. They're all mistakes with the code. There was one more I wanted to look at here. And this. I'll indent this code and fix it. There's an awful thing that can happen when you're working on a large piece of software where you want to make minimal changes that you can't fix style. You just have to get in there and make the changes that are as small as possible. Whoa. So beware of that in your later programming career. It can be unhelpful to fix things that don't need to be, well, in important pieces of software you don't necessarily make changes just for to improve style if you've got other tasks at hand. This is not, I'm just indenting this while I'm thinking, what's wrong with line 45? There's 3 things wrong with line 45. 4 things wrong with line 45. So I'll fix the spacing. Y. Y is a bad variable name. Not always. If you're talking XY coordinates, yeah, Y is a sensible variable names. We do all this maths with XY coordinates. So if X and Y are coordinates, yeah, great. Call your variable Y. There's nothing wrong with calling a variable E if it really holds the constant E. Short names can be okay if they're meaningful. In this case, it should be called die2roll. This name, can you have a worse? Well, there are 2 things wrong here. Is that really a constant? We have a rule that it's important to be able to tell what's variables or not. So if that was a constant, the style rule is put it all in uppercase. So hash define anything, and it should be uppercase, so we know down here without looking back, maybe we haven't even read the hash define, we know without looking back it's a constant, and we should give it a valid name, which should be target roll, I guess. There are multiple reasons for this. I'm not going to keep going through this. I'm going to show you some more examples just to recap them shortly. But I want to make a couple of remarks. Now, I'm not saying there's just one way to space programs and indent programs, or there's not just one style. There are sort of groups of styles out there. There are 3 or 4 popular ways to indent and space C programs which coders use. Just pick the one that's in this course, use it for now. When you've finished COMP1511, you can go off to it and use a different style if you like, but let's walk before we run. Just follow the style we're using in the course when it comes to spacing and indenting. What this means though is if you're looking at reading tutorials you found on the web, you may find them written in a different style. There's nothing wrong with that, as long as it's done consistently. When you get a job as an intern at a particular company, if you end up writing C, you may find that the team you work on has a particular style. There might even be a company style, and you have to follow that just for consistency. So they're all used to seeing this style, and all the code is just in this familiar style. Doesn't mean their style is better than the style we use in this course. The style we use in this course is a very much a classic one. It's very close to what they use in the Linux kernel, for example. It's very close to what the original C authors use. Not identical. It's got some things in it that are chosen to be particularly suitable for this class. So that's one thing about spacing and indenting. Now when we talk about choosing good names, that's everything. Everyone should be doing that. That's something we all should be doing. So that's a universal. This putting hash defines in capitals, that's almost universal. I have seen people saying they don't do that sort of as part of their style, but that's almost always done. So yeah, by following style, some of these style rules are just everyone does them. Some of them you're following the specific layout we use in this class, and it's no better than other consistent rules, but we're saying follow our consistent rules. One thing you'll see is we'll give you code for assignments and things like that in this style. So your style will fit with this style. It'll make it easier for reading. Some general points about style. Let's go back to some specifics. Alright, yeah. This so much. I see students do this, and it makes me cry. They write their assignment, so it's assignment 2, and they write 300 lines of code, and it's a complete utter mess. And then their plan is on Friday, if it's due on the Saturday, the Friday they're going to spend fixing the style. Don't do this. Don't write your code in good style from the start. It will help you. You'll write your code faster. Everything will be faster. Don't be one of those people who leave style to the last minute. It hampers them. Their style is bad. It's just not good. So as you write code, put comments in your code. Often when we're coding,
comment to that.
Yeah. Go ahead, Tom.
Two major things to add. First of all, this isn't just like in the assignment, but it's also you being practiced enough in that like every time you write a piece of C code, if you've got good style, you're not going to think about style when you're doing the assignment. It's not even something that's like you worry about, because it's just a reflex if you do it right. Whereas if it's something where you only do it when you need to, in quotes, because only do it when it's marked, then you're going to have to start thinking about it. You've got to actually, remember what are the style rules, and you've got to go back through, and that's really big pain. So we strongly recommend, even when we tell you that things aren't, that style isn't assessed, which is the case in some places, the reason we don't need to assess it is just because it's better for you, and because it means that when you get to those places where it is assessed, you've actually got the practice in applying it, and it's just reflex. The other thing I'd say as well is that if you ever want help from your tutors, like Andrew said earlier, you may find that some tutors will not give you your help on your code if your code is unreadable. The reason we do that isn't because we don't like you. It's because if we can't read your code, first of all, it's going to take us a lot longer to understand. Second of all, sometimes you trying to fix up your style, in fact, is the only reason that you can find a bug, and you'll realize, oh, I was just missing a phrase, but I couldn't see it because it was in the wrong place. So two really big reasons to use good style consistently.
Thank you for that, Tom. Both good points. Yeah, so one thing I was going to say about writing comments before your code, you saw that I coded up that prime numbers thing, and we did it in steps. The classic thing to do, the sensible thing to do, is actually put a comment saying code is going to go here to count the factors, or you'll write a third of the program and put comments ahead of time saying what you plan to do here. And often if those comments can stay, or the wording just change a little to say what the code does. So we'll often plan out our code, putting in comments, code to go here to do this, code to go here to do that, and then we'll eventually write the code, hopefully, and the comment will just change slightly to say this code does that. So write comments before your code. Choose your names really carefully. That's a big one for students. They get confusing. Indent. Most students get this. Some students are recalcitrant, but tutors will help you there. Tutors will also, particularly when it comes to you can ask your tutor. So I'd actually would like tutors to mark style, give you feedback. So not mark, not assess. Feedback, help you with style on lab exercises, but we just have finite tutor time, and there are better things for the tutors to be doing. But when it comes to assignments, you can get your tutor to give you comments on your style if you've done your assignment well ahead of time, of course, and so they can give you some pointers saying, oh, I don't know those variable names or those comments or anything like that, so I don't know about that. All right. Yeah, so this is a classic example of what I'm talking about, planning ahead. So I think I'm going to do, this is the dice check, which is pretty simple, but you can do this. If statement. You might not be quite sure what you're going to do in the else case yet. You might just put the if case in there. You might put that case in there. So you can put comments in first and later replace the comment with the code, or often, as I've said, the comment then becomes explaining what the code does. So comments first. Yeah, if another person in your position, another student, if it's a lab exercise, another intern, if you're working, you've got a summer job, if they read this name, would it instantly suggest to them what the variables are used for? Does it distinguish it well? Does it separate it out from the other variables there? That's crucial, because you've got this code with 5 different variables used. Can you look at the name and instantly think, that's what that one is, that was that one? Does it distinguish? Let me repeat again. DCC be happy if you just called every variable in your program v1, v2, up to v50. It was a really complex program. You probably wouldn't do that. If you just gave it v plus number for variables, compiler happy, humans unhappy. So that's indenting, a simple example of indenting, but hopefully you've got that. Ask in your tute this week if you haven't. All right. Bad. Do not do this. Do not do this. Hard to read. It's just, this bit here is lost. You look at it visually and you've got to figure out, you've got to focus on just a few pixels here and work out, that's a semicolon, so this does this. Or it's hard to work out what's there and what's not there. There was a classic bug, I can't remember what it was was 2 years ago with Apple, where a poorly formatted if statement resulted in, I forget what the cost was for Apple, $10 million, $100 million, something like that. It was some gigantic cost to Apple. So lay out your code like this. Right. So don't bunch things together. The little equals get hidden here. This is nicer. This is not nicer. It's easier to read, easier to understand. Not so bad with the assignments, but for something like this, that just looks like ASCII art or something, a real jumble. But this becomes easier to read. Don't hesitate to put brackets in there. And it's pretty obvious. Well, you see a lot of C code with and used like that, so most coders would know that and is, it's okay to use and like that. But if you're at all concerned, don't hesitate to add brackets. We'd never complain to a student about a student adding an extra bracket saying, if you know C precedence laws exactly, those brackets aren't needed. No. Yeah, code, I mean, it is for you, but even if you don't, it's much more for others. There will be a component of your assignment mark for style. We will assess your style. More on this when it comes out. All right. there is, I should have it linked here. There is a style guide on the course webpage, which you can. It's not a bad thing to scan and read. Maybe not yet. Maybe after this week's tute, you can read it now, but you want to come back to it after this week. That tries to set out the rules. So that's some style things for you. Oh, code review. Before we talk about code, are we going into code review next week, Tom? Is that the plan in week 4, Tute Labs?
So generally what has happened is that some tutors choose to do code review. Some tutors don't, based on mainly on the fact of time and the fact that they're quite difficult to do remotely. We'll probably all do a practice code review in week 4, but then whether or not tutors continue to do them will be kind of up to timing and their classes. That's generally how it will work.
You might wonder why I'm asking, Tom, because I last taught this course term 1 2 years ago, and things have changed a bit, and we've sort of been working on how to best do code reviews. So hence I'm asking Tom what's been worked out in the subsequent terms. So I'll talk about code reviews, but there was one thing I wanted to show you here. We want that. It's going to. All right, we'll run it on this. It may be a bit overwhelming with that program. We have a style program for you that looks at your C program and tries to give you help about style. Now, it can't do everything. So it can't look at a variable called y and say, oh, that should be called second die. So it can't do that. But it can pick up some obvious things about spacing and try and give you some helpful guide to this. I'll run it on the bad style program, but I'm not sure what it's going to show. There's just too much there to overwhelm it. Your programs won't have that problem, but we'll run it. So we say 1511 style, code style bad. And it gives me lots of, oh look, so it's trying to give me advice. About spacing. So it's saying I'm getting the white space wrong. It's saying I'm getting variable names wrong. Indentation. So it's trying to point out to me, oh look, you've got indentations right and wrong. It's saying that indentation right, this indentation wrong. This is great, Andrew. Not so, oh, there's a problem there. So it's trying to point out problems with your code. It's a hard task. I think we've got it tuned pretty well, but if you think it's giving you style advice that's bad, ask in the course forum and we'll check, and if we agree we might tweak it. But 1511 style, I think we might turn it on by default with auto test from next week, when you've got more, just to try and make sure they give you instant feedback if you're not getting the style right. If you're colorblind, by the way, I'm not sure if that's really there should be a less prejudicial term. If you can't perceive red green well, which is another small fraction of the male population, you can reconfigure your terminal. You can ask your tutor about that, or ask in the course forum. All right, so that's 1511 style. Yeah, try it out. We might run it with auto test, but it gives you hints about obvious things. It can't pick up the subtle things. It can't tell you, you need a comment explaining this. It can't tell you that comment could be better. It can't tell you that variable name could be this. It might notice though that you've got all one-letter variable names and think about those. So a very useful program. Why have we got that? One of the reasons we've got that is to help let the tutor. So the tutors were spending a lot of time giving simple style advice. Like you haven't got the indenting right, so this can give you the simple style advice, and then that lets the tutors switch to the stuff that's better done with humans. Yeah, okay. Are there any questions about style that I should field?
There aren't any particularly. It might be useful just to pull up the style guide so everyone knows where it is if we haven't already done that. Otherwise, talking about code review might be useful, because there are some questions I think that would just be answered by looking at the style guide.
Alright, I'm going to try, but don't blame me if it... Actually, I'll pull it up on my local machine. 1511 style guide there on the class homepage. Ignore the URL you can see on the top of the screen. That's on my local machine. I have a copy of the class website on my local machine. So there's the 1511 style guide, link to the class homepage. Will that take me with some other useful things like the link to where all the lectures are, link for home computing, a cheat sheet for C and Linux, summary of our auto marking, our timetable, the handbook entry, the course outline. Everything linked there. It's not the prettiest web page in the world, but lots of useful stuff there for the 1511 student. Yeah, I'd say you can read this now, but some things won't make sense because they cover bits of C we haven't seen yet, or they're more for comprehensive things. They're more for people who've learned some style and then got a question about, well, what do I do now? So you can refer back. By all means, read some of this.
It's a good practice to go through every few weeks, and if there's something you don't understand, you can just skip over it, but you'll find as we go through the course that more and more of these things will make sense, and you'll be like, oh, I know what that is, and that's quite useful. There was a question about is it possible to get a few additional exercises that aren't assessed for us to code up and post on the forum so we can critique each other's style? That's a good idea. Generally, we don't allow posting code on the forum, but I'm sure we could make a post. Well, first of all, we've got code review, as Lucas says. So some tutors will do that, certainly. We could probably make a forum post, though, that has some of the revision questions from the tute where people could post their style if they were interested. That might be something we can explore. So keep an eye on the forum.
That's an excellent idea.
We can do that.
Yeah.
Okay, I'll have a chat to the forum gods and we'll see what we can make happen. But okay, cool.
All right. Code reviews. Yeah, having other people look at your code, discuss your code. So you might have a job as an intern, and your manager will say to you, work on program X. We need it to do Y now. So you might put together some code to do Y, and you test it away, and you think it works. You wouldn't necessarily just get added to program Y. What more commonly would be you'd show it to other members of the team and get their comments. Perhaps get them to agree it's safe, correct, they like the style. Perhaps they'll tell you to go, suggest you go and make changes. They'd review your code. Avoid if you end up working, what was the company called? Fastly, and you bringing down 10% of the world's internet by making a mistake. All right. So review is a good thing. I'd say it's orthogonal. It's a different way of examining code. We can there are various ways we can look at code to help us be sure it's appropriate. One is we can run automated analysis of the code, and DCC does that to some extent for you. It'll flow through things and look for things that don't make a lot of sense in ways you've used variables or things like this. Just the most simplest thing is you've declared a variable and not used it. Why? What's that about? Is that a sign of a bug in your code? But another way is testing. So you can have a set of automated tests where your program's given input Y, and if it's testing primality, you check that it says no if Y or yes. So a series of automated tests. Automating testing can get quite elaborate. You can get things for programs that, for example, provide a website. Your automating testing thing may sit with a web browser, clicking buttons on the web browser or adding things to fields, using a sort of add-on to the web browser. But humans, there are so many things that humans can check as well. Yeah, so it's like writing proofreading. All right, and we'll do this to some extent in the tutes. Yeah, it's a great way to learn. All right, in our labs, there's the opportunity to work as pairs with people online and things like that. It's not happening as much as it used to, but that's not a bad way to do that. Using software tools. A lot of code review will happen via code repositories, which you'll see in COMP1511. Right. If you're pair programming, if you're working on pair programming, let me say be very careful here. Assignments are solo exercises. Weekly tests are solo exercises. So you can't pair program for those. Lab exercises we've set up optionally so you can pair program. If you pair program, there's some suggestions for how you might work. Discussion as you go, thinking, talking, putting your code into words is fantastic. There's a thing we see over and over again where a student has a problem, so they come to you to explain the problem, and they talk through their code. They say this while statement does this, and then it comes in here, and this if statement's meant to do this, and it's meant to do, but that doesn't happen. And as they're talking, explaining, and it's meant to work because the variable y does this, and suddenly you'll see, oh wait, I understand my bug. I'm going away now. That's perfectly normal. We see just the act of explaining your code can give you insights into your code. So you're talking and explaining the loop you've just written to someone you're pair programming with gives you insight.
Two things on that quickly. The first one being one of the pieces of advice that we would give if you're pair programming, especially if you're submitting work that you are pair programming, it is vitally important that both of you have contributed to the code equally. So what we recommend is one person is the hands, the other person is the brain. And the idea behind that is it shouldn't just be the person who's got the keyboard typing is also doing the thinking. It should be the other person sitting next to them doing most of the thinking, and the person who's doing the typing who just sort of occasionally like, oh, what about this? So it really should be that you're both working together. It shouldn't be that there's somebody sitting off the side. The other thing as well that is super important is that, if you got one person who's done the first lab exercise and they were the one who typed it out, swap out, get the other person to type the next exercise, so that you're actually both switching between roles of thinking and doing typing. It is really, really productive, but it only works if you do it well. If you just have one person sitting at the computer, the other person is not going to be paying attention. The second thing to that is also, that also goes for if you're helping people. So sometimes what we see is, students will be on the forum or sitting next to a friend in class and they're trying to give them help. It's the same thing of don't just jump in and help them straight away. You can have this idea of the shared, you're giving them suggestions while the other person's typing, but don't just try and come and fix their code. The last thing I'm going to say is just an anecdote. If you were in my room, which hopefully none of you are, but you would find that there are some rubber duckies which are sitting around. There's two I can see on one of my desks, and the other one is sitting right in front of me. I got these as a birthday present from one of the other tutors in the course because rubber duckies are incredibly useful. What you can do, buy yourself a rubber ducky, and whenever you've got a problem with your code, talk to your rubber ducky and explain what the problem is. It's just like having a tutor, except you haven't actually gotten the tutor over. And because you are trying to explain to this beautiful rubber ducky, exactly what is going on in your code, you can often get the same benefit that you would get from just talking through your code to yourself, except you're talking to somebody else. So I would strongly recommend getting yourself a rubber ducky. Failing that, find a willing, housemate or a grandparent who you can walk in and just explain the code to them, because that is a really great way of finding bugs in your code.
I would say to you, by the way, you won't be able to do it in 1511, but as you go further on in coding, you can replace rubber ducky by attempting to do mathematical proofs about your code as a way of thinking. So rather than talk about your code, you can try and sketch out a proof, a formal proof that your code does what it's supposed to do when it doesn't want to do, when it's not working, and often that's a way of finding a bug.
In fact, Andrew, next week, one of the lab exercises, one of the challenge exercises, there is an extra challenge which is not marked at all, where we talk about, can you figure out a way to prove that your code works, which might be interesting to some of you.
Nice. All right. Saying, why are we getting you to pair program? There's actually really good evidence that pair programming is a nice way to learn. It's a faster way to learn coding for a lot of students. So you will have to, in many situations, code alone. So we've got you coding alone. You definitely want to be switching roles, as Tom said. I would say, yeah, you want to help someone in any sense with coding. You never touch their keyboard. So you don't get in there and fix their program. You might give them advice. Your tutors are very good at this, giving you just the advice to help you learn. But you're not helping someone by grabbing their keyboard unless their computer's on fire and you know how to put the fire out. All right. So code reviews can be a bit hard for your ego. You've put a lot of work into this code, and there are things that could be better, you discover in the code review. That's pretty normal for most of us, let alone people who've been programming for only 3 weeks or 4 weeks. So code reviews, you've got to sort of steel yourself that you will discover your code could have been better. If you're doing a code review and pointing out to someone that they're something that's a better way, what is effectively a better way of doing it, it has to be done very politely, gently, constructively. And if you're a COMP1511 student, don't be too confident what you're saying is better is actually better. Even when talking to tutors now, after far too many years of coding, I'm not always confident about, when they do things one way and I do it another, which one's better. So things may be, there may be different ways to do things, but are they better? Well, you can discuss, understand, discuss, look at different ways, see different ways. Often it's exciting. It's often really cool and interesting to see someone's done things in a completely different way that you just didn't thought of. It's suddenly insight. Oh, well, that's clever. That's a different way to do things. Get that a lot from students with particular challenge exercises. A student will do. You think, oh, I never knew you could do that way. I had a solution, but they've got actually a different way, and it's just cool to see something that's different. Yeah. So we're talking about the code and discussing it in a very friendly environment. Yeah, things not to say. Put up your hand and say, I can see 7 mistakes in this code. So, and it's not just this course, by the way. So if you think behavior like this is going to help you when you get a job or an internship, no one wants to work with someone who behaves like this. So yeah, it seems tough, doesn't it? All right, so for at least for the first time we do it, the tutor will actually put up their code. You're still not going to say these things, so you're going to practice not saying these things, being constructive, polite, talking about the code. But we'll get the tutor to be the person who puts up their code. And in subsequent weeks, we'll do this. And you're saying, Andrew, tutorials make me anxious at the best of times. I don't want my code judged. If you're someone that gets incredibly stressed by this sort of thing, we're not going to make you do this. So just have a word to your tutor saying, it's all I can cope with now. I can't display my code. Your tutor will understand. But also, try, if you're not too stressed, you're not too anxious about this sort of stuff, try to be brave and put your code up here and learn some more and get people to look at it. Understand that you've been coding for 3 weeks. There's no reason why you'd be writing perfect code. It comes over a much longer period of time. Yeah, so we'll do some trial reviews next week, but after that the tutors will judge how much we're doing. But tutors may particularly talk to people who are doing okay with the coding, get them to put up their code. Often you want the best code reviews are someone who's solving the problems, so they're doing pretty well. They're sort of heading for at least a distinction in the course. They're solving the problems, but there's, like a learning code, there's some things that just could be thought about, done differently. Style could be better, things like this. Alright, so, in fact we've run out of time after all of that. Alright, so functions, I'm sorry, we'll have to wait for next week. Tom, is there anything more we've got to say? We've run well over time. I wasn't watching the clock.
No, I think that's the main list of things to cover, and yeah, probably good to end the lecture here, I'd say. Alright,
so apologies for that. I didn't time that very well. hope you're not late for your next tute lab, but we'll start in on functions in Thursday's lecture. So I'll talk to you all on Thursday at 2 o'clock. See you all then.